In this section we need to cover some of these basics. First we cover what are automations, AI automations and AI agents. Then I want to give you a broad overview of the platforms that can be used, for example Zapier, Make.com, N8N, the LangChain ecosystem, with LangGraph, Flowwise, CrewAI, AutoGen and a lot more. If we build stuff, we work with APIs. That's why I also need to explain to you what an API exactly is. The brain of our automations is always an LLM, and I also want to explain you in more detail what an LLM is and how an LLM works. You will also learn what tokens are. You need to understand this because I also show you what the OpenAI API is, how to work with the OpenAI API, and how these tokens are priced and what model you should use, because we have also models with test time compute and a lot more. And you need to understand how to create new projects, new API keys, and how to manage all of this. Then we need to take a closer look at function calling. So basically what is function calling, because our agents can use tools. That's called function calling. And you need to understand what are vector databases, direct technology and embeddings models. Like I said, if you already know all of this, you can skip through the whole section. But I would strongly recommend you to understand these basics, because you need to understand this later in the course. I have already explained some of these concepts in other courses. So this is basically a theoretical overview of all of these concepts, of APIs, of tokens, of LLMs and much more. So see you of course in the next video, and if you want to dive straight into practice, you can skip this section. But like I said, I would strongly recommend you to understand these basics. What are automations, AI automations and AI agents? Before we can start build out these things, we need to define some words. So let's just dive straight into it, because there is a lot of confusion out there. So first, if we simply ask ChatGPT, define the word automation in a short way, ChatGPT tells us automation is using technology to perform tasks automatically without human intervention. And that's basically the easy explanation. This is a normal automation, so no AI automation and also no AI agent. What we need for these automations, because we can absolutely make normal automations. For a normal automation, we always need a trigger and an action. So basically, if, then. If people give us their number, we should call them back. And if we automate this would be an automation. Now something that can happen but don't have to happen, a cascade of events or more triggers and actions. Let me show you one of the simplest automations out there. Also one of the first automations that we will build later. This would be a really simple automation that we will build. Basically we have here a trigger node and an action node. And what does all of this mean? Basically this trigger is an on-form submission. If we simply press test workflow, you see that we get here an on-form submission. You can embed this into web pages, do whatever you want. Basically if we type here in, for example, our name, let's just say Arnie, and I want to have, for example, the deluxe room, I can simply press submit. And then my workflow will get executed. So this was the trigger and now the action gets executed. The action basically was that we have connected our trigger node with Airtable. Airtable simply uses the API. We will simply throw in the data in my Airtable sheet automatically. So you see Arnie deluxe room. And if we do this again, it works again. So test workflow, this thing pops up. This time my name is Bob and I want to have a single room. I press submit. This thing will get executed. Then I come back here and Bob wants to have a single room. So this works completely automatically without human intervention. I can embed this on-form submission into a website and I don't have to do anything, and my data gets stored over an API in Airtable. And of course I will show you exactly what's an API, how all of this is working, so don't worry, we will do this slowly, step by step. And by definition, this would be an automation, because we used technology to perform a task automatically without human intervention. People can type in their information and the task gets executed, this data gets stored into my Airtable datasheet. And we used the simplest way, the stuff that we always need, a trigger and an action. This is right now no cascade of events, and we don't use more trigger nodes, and we don't have more actions, so this is the simplest automation that you can build. And by the way, these triggers can be anything. You can trigger these things over WhatsApp, over Telegram, over emails. If you get the email, if you get updates in Airtable, updates in Google Sheets, It could be a time trigger, it could be a webhook, it could be on-row edit by Google Sheets, it could be anything, and I will show you everything that's possible. Basically, you have a lot of options here. I will show you all of them. So automations, check. What's an AI automation? An AI automation, at least how I see it, is basically the same thing, but with an LLM included as the brain. Basically an LLM like ChatGPT, like Claude, like Gemini, DeepSeek and so on, Llama. A LLM is the brain and can make decisions here. It can, for example, summarize data, convert data, make sentiment analysis and a lot more. As soon as we have an LLM included, we have an AI automation. Because we don't pass just variables through these automations, we will convert these variables intelligently with AI. And also don't worry if you do not know what LLMs are, how LLMs work and so on. I will show you this in more detail, of course. Basically, ChatGPT is an LLM, and these things can simply work as the brain in our automations. Our AI automation is basically something like this. Once again, we have a trigger, and we also have an action that will occur. This is a sentiment analysis. People can simply once again use a non-form submission, tell us if they are happy or not. Then our brain, the LLM, will make the sentiment analysis, spits out just one single word, and then this word gets stored into Google Sheets. Let's just test this workflow so that you can see it. We press test workflow. Let's just say my name is here Peter. And let's just say Peter likes to write fluff in his reviews. I am super impressed by the service in this location. The room was clean, I love that everybody is nice, nobody tried to rob me, I also got a bit of water. And you can see that there are also some typos, and everything is completely fine. Our LLM will simply look at this thing and then do everything autonomously. So let's just send this out, let's just press submit. Our LLM will simply think and make an analysis, give us simply one single word, and everything gets stored into Google Sheets. And everything that we got is of course Peter positive into our Google Sheets. Because the LLM, the brain of our automation, was smart enough to make a sentiment analysis. This would be a really simple AI automation. And now you know what an AI automation is. Before we go on and define AI agents, I want to tell you that just with these two things you can do so many things, even if just with trigger and action. Because here in N8N you have so much different things. You can trigger your things manually, you can use on-app events, and here you can include everything as a trigger node. So you see, you can connect really nearly every single thing that you can think of. This will never ever stop if I don't stop scrolling. So you see, you can really do a lot with this thing. You can use unscheduled triggers, and for example, post on social media every day, like 2 times or 3 times or whatever, completely automatically. You will get this scheduled trigger. You can use on webhook calls and call N8N out from other automations. You can use this on form submissions. You can use when executed by another workflow. So basically you can build other workflows and call N8N and make then your normal automations. And you can use human in the loop. So basically, even if you just make normal automations, the possibilities are completely endless. And now let's talk about AI agents. Basically, it's once again the same thing as an AI automation. But this time the brain also has tools that it can use. Or it can call or talk, let's just make this right, to other LLMs. Let me show you an AI agent. This would basically be an AI agent. Now why is this an AI agent and what can this AI agent do? So let's just see what this thing is doing, and please don't be worried. We will do this slowly, step by step. Basically we have once again a trigger node. This time we trigger over Telegram, so we can simply either write to this thing or talk to this thing. Then this thing is our so-called AI agent, our brain, the LLM, and because the brain has tools, it's an AI agent. Now what does this mean? I can simply talk to this thing and use these tools. And here you see one tool that is called Gmail Summary. So I can basically say to this thing, summarize my last 5 emails, and I will get a summary. I can also say to this thing, write a mail to Arnie, invite him to my birthday party, and this thing will send an email. I can use the calendar set to insert new data in my calendar, and I can use the calendar get to see what's on my calendar. And it also remembers the stuff that we are talking about. And this thing also writes back to me in Telegram. This would be an AI agent. And don't worry, like we will do this step by step. And now I want to show you a big AI agent. Now this is basically a big AI agent. Here we have, for example, once again the same triggers. Telegram, we can write and talk to this thing. We use OpenRouter with different LLM models. We have an AI agent and a basic LLM chain, so that this thing can also talk to us over Telegram. It can write to us over Telegram. And then this thing is special because it uses a lot of sub workflows. If I tell to this thing, write me a post on X, this sub workflow gets executed. If I tell to this thing, search me the newest information about Hacker News, it will use the search agent. And the research agent is basically this. So this thing gets called from our other AI agent, and this thing will then go on and search Hacker News or the SERP API from Google or Wikipedia or whatever. And if I ask this thing something about my emails, it will go on, trigger the email agent, and the email agent can basically do everything in my emails. It can label emails, it can get the emails, it can mark as read, mark as unread, and so on. So basically this AI agent has tools, and not only tools, it can also talk to other LLMs. It can write, but it can also speak. It has a second LLM chain. And we can switch the brain with different models. So this is a really strong AI agent. And also here, don't worry, like we will do this step by step. Especially about AI agents, we have a lot of definitions. And in this course, I want to tell you also the definition from Andrew Karpathy. Basically, if an LLM has tools, you can call it AI agent. BotPress has also a gigantic article that wants to tell us what's an AI agent. But as soon as an LLM has tools, we can call it agent. You can see an LLM more or less like a computer, and the context window is the RAM. Don't worry, we will define the LLM in more detail. And the LLM can basically speak to other LLMs. It can browse the internet with these tools. You can simply generate audio or get audio back. You can also generate video and get video back. This is right now, let's just call it in beta, this is not that great. But you can use different tools, for example, Python interpreter, terminals, and so on. And you can see this as the standard software 1.0 tools, like a classical computer. And you have also a file system with embeddings with the RAG technology. Like I said, don't worry, I want to explain this in more detail over the next videos. Andrew Karpathy has also this graph, and as soon as more LLMs start to talk to each other, we can use, for example, one LLM as the CEO, and every single one of these LLMs can have, for example, more tools, just like you saw in our previous example. So the CEO can, for example, use other LLMs, and every other LLM can do specific things. You saw it here, this is the CEO, and the CEO has an employee that is called the Gmail tool. The Gmail tool has also an AI agent as brain and has more tools to use, just like you see here. The CEO has different workers and it will simply manage these workers, and every one of these workers is, for example, expert in one specific thing. Karpathy calls them CFO, CTO, COO, General Counsel, Chief Scientists, and so on. And you can basically build entire organizations with these AI agents. This is really powerful, and I do think that we will completely go into this direction more and more over the next years, because these things start to get useful. By the way, as soon as one of these workers also uses tools, we call it function calling, but don't worry, I will explain all of this in more detail. One last quick summary. Automation is using technology to perform tasks automatically without human intervention. In order to create an automation, you need a trigger and an action needs to occur. It can be a cascade of events with more triggers and more actions, but also just one action is enough. As soon as we talk about AI automations, we have the same thing, but with an LLM as brain included. And if we talk about AI agents, it's once again the same thing, but this time the brain also has tools, or it can call other LLMs or talk to other LLMs. So basically we have one CEO that uses different tools or can call other sub-workflows, and then you have an AI agent. So the LLM can basically write the email and then use the tool to send the email completely autonomously, without your intervention. And a trigger could be anything. It could be from WhatsApp, it could be from email, it could be a on-form submission, it could be from Google AdSense, it could be a Facebook lead, it could be on-row edit on Google Sheets, it could be, like I said, whatever. And also the action can be whatever. So congratulations, you know what we will build. Most of the time we will use N8N. We also use Flowwise later and some other tools, but like I said, most of the time we use N8N. Because this is a gigantic and really cool tool. And don't worry if this is a little bit too much for you, at least right now. You will learn this step by step, and in the next video we will start with the basics. I want to show you what an API is. And of course, if you already know what an API is, you can also skip the video. You already know that we can build a lot of different agents, automations and so on. And every single one of these automations has included an API. Or a few APIs. In this example we have this AI agent. This AI agent uses ChatGPT in the background, and in order to use ChatGPT we need to make API calls to OpenAI. This agent has also included Pinecone. Pinecone is a vector store. I want to show you exactly what a vector store is and how all of this is working, but basically we also use an API to communicate with this vector store. We have also Google Sheets integrated in this agent, and also Google Sheets has an API and we can talk with Google Sheets. So basically before we dive deeper, I want to tell you in this video exactly what's an API, because you need to understand this in order to build out such automations and agents. The best explanation of an API, at least in my mind, is on AWS. So this is from Amazon. So what is an API? APIs are simply software components to communicate with each other using a set of definitions and protocols. For example, the Weather Bureau software system contains daily weather data. The weather app on your phone talks in this system via APIs and shows you daily weather updates on your phone. So think of it this way. You can simply connect two different software pieces and they simply talk to each other. So you can connect, for example, your phone via this weather app, and then your phone will send a signal to this weather app. The weather app will send a signal back, and all of this works via the API. This is an API call that your phone sends out to this app. What does API stands for? API stands simply for Application Programming Interface. And in the context of APIs, the word application refers to any software with a distinct function. Can be thought of as a contract of service between two applications. This contract defines how the two communicate with each other using requests and responses. Their API documentation contains information on how developers are to structure those requests and responses. So in the API documentation we can simply see how these apps talk to each other. And we will make this really quick. So how do APIs work? To make it really simple, we have always a client and a server. So the application that is sending the request is called the client, and the application sending the response is called the server. So in the example of the weather app, Barrow's weather database is the server and the mobile app or your phone is simply the client. Then we have a lot of different ways to communicate with APIs, but I think we don't need to know all of this. The rest of the APIs, you can read this yourself if you really want, but for me this is not really relevant for the stuff that we do. So in this video you have simply learned what an API is. An API is simply a connection point of two things, of two softwares. For example, if you connect your mobile phone with, for example, this weather app, you have the client and the server, and we can simply talk to each other. So the client, your mobile phone, asks to the server something and the server communicates back. So we can simply plug in one software into another software, and that's basically an API, and we will use APIs over the next lectures and also over the next sections. So in our first example, this would simply mean that we are communicating with Airtable over the API. It's really that easy. We have client and server, and we simply send out requests and the API will execute our action. And that's an API, and of course we will use a lot of APIs over this course, and that's why you need to understand what an API is. In this video I want to give you a brief overlook of some of the platforms that are great for automations, for AI automations and also for AI agents. Yes, this video will be a broad overlook, but later we will dive in specific details. I think you should know what's on the market and what are the strengths and the weaknesses of these tools. The first tool, or one of the first tools, is Zapier. Zapier is around for a long time, and in Zapier you can make basic automations, but I have to tell you, Zapier is a little bit limited, and you also need to pay sooner or later for Zapier. But if you want just to make really simple automations, you can think about Zapier. We will not dive into Zapier in detail because I think it's not worth our time. The next platform is Make, and I have to tell you, Make is generally speaking a great platform, but we also have some downsides. We are not able to create complete AI agents. We are able to make automations, we are also able to make AI automations, but we are restricted with agents and we need to pay for this tool sooner or later. Then we have n8n, and I think n8n is one of the best platforms out there. n8n is gigantic. We can build everything, automations, AI agents, and is also completely open source. We can find the source code on GitHub and we can install it locally and also use it for free. We have also the option to host it, but I think n8n is one of the best tools out there. And that's why this tool also exploded in popularity over the last months. Like I said, I think n8n is one of the best tools and we will have a strong focus on n8n in this course. Then we also have LangChain. LangChain is one of the original tools. We can also use LangChain in Python. The LangChain ecosystem is really big and they work with a lot of different companies. Under the LangChain ecosystem, we have more. We have, for example, LangGraph, and LangGraph is also able to create AI agents. And with LangGraph, it's also a little bit easier because we also can work visually. Besides that, we have also LangFlow. LangFlow is basically built on top of LangGraph. It works in Python and you can do a lot, but I think if we want to work with the LangChain ecosystem, we should use Flowise. Flowise is a really great tool. We have a drag and drop interface, we can do nearly everything, and in the background works LangGraph. So basically this tool works in the background of Flowise, and in Flowise we have a lot of things that we can do. And at the end of this course we will also take a few lessons from Flowise. We will connect Flowise also with n8n. Then we have AutoGen. AutoGen comes from Microsoft. We are not really able to make automations. This is just for AI agents. I think AutoGen is a little bit hard to use and I do not like it that much. But nonetheless, I want to tell you that AutoGen is here. And if you go to the GitHub profile, you see that AutoGen is also open source, and you find also the whole installation, and if you scroll down a little bit more, you can also find some courses about AutoGen that are completely for free if you want to take them. Like I said, not one of my favorites, but I want to include it here. Then we have CrewAI. CrewAI was one of the most popular tools a few months back, but I think n8n steals the spotlight right now against CrewAI. Besides that, we have Swarm. Swarm comes from OpenAI directly. It has also some stars on GitHub because it's open source, but I think Swarm, it lacks a little bit of features. It's not perfect. I just want to bring it up because it comes from OpenAI. Besides that, we have Agency Swarm. Agency Swarm is specifically for AI agents. You need to work with Python. It's a little bit complicated to use. It's highly customizable, but I don't like it. If you want to use a really easy interface and if you do want to pay for these features, you can also think about Vector Shift for a brief moment. Besides Vector Shift, we have also VoiceFlow. Also, this tool is similar to Vector Shift, and we also have BotPress, and BotPress is generally speaking also a good platform, but BotPress is really expensive. BotPress is really easy to work, but if you come to the pricing, you see this right here. If you use a Teams plan, you need to pay $445 a month. I think this is like completely over the top. And that's why I love n8n so much. So basically you have learned that we have a gazillion frameworks. We have Zapier. I think it's good for automations. We have Make. Make is great, but not for AI agents. We have n8n, and n8n can do everything. Automations, AI agents, you can use it for free. It's the most customizable tool. I just think you will not find a better option. Then you have the whole LangChain ecosystem, and the whole LangChain ecosystem is really great. Also if you work in Python, and if you want to use it in an easier way, I think you should use Flowise, where LangGraph works under the hood. And I want to also show you Flowise later in a little bit. And besides that you have AutoChain, CrewAI, Agency Swarm, Swarm from OpenAI, CrewAI and a lot more, and I don't think this is really worth our time. So basically n8n is the tool that we love to use. But nonetheless, I wanted to show you that we have a gazillion tools. There are also a lot more, but I think these are the most popular tools out there, and I think you should absolutely know what's out there, because you never know. Maybe one of these tools make a really great update, and then we can adapt. I will include new lectures and we use another tool. We are not married to one of these tools, but right now, at least I think I am a little bit married with n8n. You have already learned that our AI agents or AI automations always have a brain. The brain is an LLM. So if you basically click here, you see that ChatGPT in this case is the brain of our AI agent. I have to tell you right now that we have a lot of different LLMs. We have, for example, Grok. We have the GPT models, we have the Gemini models, we have the DeepSeek models that are open source. We have Qwen models, we have Claude models. We have Llama models and basically a gigantic amount of different LLMs. But in this video you have to learn what an LLM is, so that you understand how the brain of our AI agents is working. It's also important that you understand tokens, because you need to pay the tokens that you generate over the API. And we will do it really simple. We will use an open source model just for the sake of this tutorial. As an example, we will use a Llama model as the example, because with these Llama models we can see exactly what's inside. But all of these LLMs, they are trained completely similar. It does not really matter about what LLM we are talking. Basically they are just two files. And we make just a simple example with Llama 2. For everybody that already knows exactly what an LLM is and how it works, of course, you can skip the lecture. Basically, an LLM is just two files. We have one file, and this file is basically the parameter file, and I simply make it here as P. This stands for parameter. And we have a second file, and the second file is just to run these parameters. I just call it run file. This run file is most of the times written in C. C is a programming language, or in Python. So both of these can eventually work. So what we have right here is the parameter file and the run file. And the run file most of the time is simply 500 lines of code. So we use 500 lines of code to run this file. And this file is where the magic happens, because this file is gigantic. We make an example with an LLM that is open source. And the LLM is called Llama 2. So Llama is of course the LLM from Meta. I simply call it Llama 2. And they have different models. And this Llama 2, where we make this example, this is the 70B model. So this simply means that we have 70 billion parameters. So you know, like, this is a relatively big file that we have right here. This file is basically this parameter file. So this parameter file has 70 billion parameters. And how do we get all these parameters? We need to train this file, and we train it on a lot of text. We use 10 terabyte of text in order to train this file. So we use 10 terabyte text. This is text from all over the internet. So this could be Wikipedia articles, websites, and much more. And this file, we can simply compress this file down, and this file is only 140 gigabytes big. So this file is just 140 gigabytes big, and we train it on 10 terabyte of text. So you know, we can compress it down really a lot. This parameter file, you can simply think of this file just like a zip file. It simply compresses down all this data. And in order to compress this data, we need a lot of GPU power. So we need a lot of GPU power in order to compress this data. And that's also why Nvidia was such a great stock over the last years. If you look, for example, at the Nvidia stock, you see we have a gigantic run-up. And this is basically because everybody needs GPUs. So you see we have a gigantic run-up. We basically started somewhere down here. So this was November of 2022. And here comes ChatGPT online. So the normal ChatGPT that most of the people know. And then it was relatively clear that we need a lot of GPUs in order to train these models, and this stock got on a tear. But this is not about stocks right now. So basically, we use a lot of GPU. I make this really simple. I also have more detailed explanations, but I don't think we need this in this course. In this course, we only need to know that we need a lot of GPU in order to compress 10 terabytes of text down into a parameter file. The parameter file is similar to a zip file, so we simply compress 10 terabyte text into a 140 gigabyte file. And this file has 70 billion parameter, the parameter file. And then we have the second file. The second file is the run file. It's just a few lines of code. And if we have an open source LLM, just like Llama 2 or even Llama 3, or whatever open source like that you want, we can download this file and we can run these files locally on our PC, and this brings us maximum data security because nothing goes over the internet. If you use a closed source LLM, the biggest downfall is that you need to use either a web interface or their API, so you can absolutely not download these two files. You cannot run them locally. This is the biggest downfall of closed source LLMs, at least in my mind. And the thing is, with these two files, they are a little bit magical, because here works the transformer architecture in the background. You can simply think about a neural network. We don't need to dive that deep. But basically the neural network sees words and predicts us what next word comes most likely. So it works basically like this. We train on all this text, and so the LLM simply learns how text is structured. If we ask, for example, what should I eat today, the LLM will simply predict what words a human will most likely hear. So this is simply called the pre-training. And with the pre-training, we simply hallucinate stuff out of this file. But then comes the second thing. The second thing is the fine-tuning. And with the fine-tuning, we give the LLM a lot of examples how humans want to have their response. So we would feed, for example, a question. What should I eat today? And then we would feed an answer that humans like. For example, you could eat steak today. And if we feed this over and over and over, the LLM learns how humans want their responses. This is called the fine-tuning, and this is the second part in order to run LLMs. And of course, on open source LLMs, we can even fine-tune ourselves, because we get access to these base models, to these pre-trained models. And then the last part is the so-called reinforcement learning, and we can break this down really simple. After the pre-training and the fine-tuning, we will simply do this reinforcement learning. This basically means that we ask a question, we get an answer, and then we tell the LLM if this is good or not. This is basically the reinforcement learning. So we have 3 phases of training. The pre-training, we simply use a lot of GPU to compress a lot of text down into a smaller so-called zip file, and we can hallucinate text out of these. In order to make these hallucinations better, we do the fine-tuning. So we feed a lot of questions with answers structured in a way that humans like. And in this phase, the LLM learns how humans want the responses. This is a lot cheaper. We need less GPUs. We do this with roughly 100,000 examples. So you know, the pre-training 10 GB of text, the fine-tuning only 100,000 examples and a lot less GPU. And lastly, the reinforcement learning. We simply take a look, hey, makes this sense or not? If yes, thumbs up, if no, thumbs down, and the LLM will simply learn further how we want our responses. Now the next thing that is really important is, you have already learned it, in this transformer architecture there are neural nets. And neural nets, they work with weights. Basically they work with numbers. And in order to make sense for the neural net, of course, we need to have numbers. So the first thing is, of course, if we feed a question into an LLM, the LLM will make numbers out of these questions, the so-called tokens. These tokens are numbers, and with these numbers the neural net can make its calculations what word will come most likely as the next word. So I want to show you simply how these tokens are structured. If we go on this tokenizer, we can see it. We can simply type in, what can I eat today, for example, and now you see we have 5 tokens, 20 characters, and the tokens are structured in this way. And if we press here on token IDs, so this is basically what the LLM sees. The LLM sees numbers, and with these numbers the neural net can make its calculations and gives us a good response. If I press right here, for example, on clear once again, then go on show example, you see a bigger example. And here you also see that not every single word is one token. This gets divided a little bit different. So here you see invisible is, for example, 2 tokens, and here this point is also a separate token. So we have a lot of different tokens, and if we press on token IDs, you see this is basically what the LLM sees, and the LLM makes its calculations out of these tokens. But why I show you this? Because this is important, because we have a token limit. Every single LLM has always a limit how many tokens it can understand right now. If we go on this article right here, what are tokens? OpenAI tells us that a token is roughly 4 characters in English. It means that 1,500 words are roughly 2,048 tokens. And this is important because every single LLM has a different token limit. You can see it down here. Right now, at this minute, GPT-4 Turbo and also GPT-4 Omni and a lot of other models, they have roughly 128,000 tokens as token limit. We have also models that have 2 million in token limit. We have also smaller open source model that have only 4,000 token as token limit. And the important stuff is that you understand that as soon as this token limit is reached, the LLM will no longer understand the things that you talked previously with the LLM. I just want to show you an example into ChatGPT. I simply tell the LLM, write a story about a fox, and now our first tokens get generated. And as soon as we are close to the token limit, so as soon as I talk, for example, about other stuff right now, let's just assume that I want to have different stories right here in this chat. For example, tell me a story about a frog. Right now, of course, new tokens get generated. And as soon as we reach our token limit, the LLM will no longer know our previous question and also not the answer, because the LLM always just knows the last few tokens. In this case of ChatGPT, the context window is relatively big, so it knows 128,000 tokens. These are roughly like 100,000 words, roughly, like I said. And after it, it will no longer get what we talked previously. So please remember, always the last few tokens count, and everything that is over it will no longer be in the knowledge of the LLM. You can call it this way. Of course, we have a lot of techniques to increase this knowledge, for example, the RAG technology and so on. We will talk about this later. But for now, you need to understand that every LLM has a token limit. Eventually, this will go away. Eventually, the token limit will be so big that we no longer need to think about it. But right now, at this minute, we have these limits and we need to know this. So basically, if you ever wonder why the LLM no longer knows what you talked about previously, it's simply because the token limit is reached. And we have a lot of techniques to make this work a lot better, and of course over this course you will learn how. Another concept that you need to understand is, as soon as you are generating these tokens over the API from OpenAI, you need to pay. You need to pay for every single token. But more on that of course in the next video, because in the next video I want to show you exactly how the OpenAI API works and how much you need to pay. And if you use open source models, of course you can generate these tokens on your local machine without paying anything. So in this video you have learned how an LLM works. Basically, we have just two files. We have a parameter file and a run file. The run file is just some code to run the parameter file. And the parameter file is simply a lot of text from the internet, but it is compressed down into a small file similar to a zip file. We need a lot of GPU to do this. This was the pre-training. After the pre-training comes the fine-tuning. Here we feed the LLM questions and answers so that the LLM can learn how we want our responses. And after the fine-tuning, the final step is the reinforcement learning. We simply ask questions, get answers, and rate the answers if they are good or not. And with this last phase, the LLM will get better at these tasks. Then you have also shown that in the background works the transformer architecture. These are neural nets, and neural nets, they make calculations with numbers. And that's why we need to divide our words in tokens. And with these tokens, we can make the calculations and calculate what word comes most likely as the next word what we want to have. And you need to understand these tokens because every LLM has a so-called token limit. And as soon as the token limit is reached, the LLM will no longer know about what things you talked previously. It always looks at the last few tokens, and of course this token limits is the model dependent. Sometimes it's 4,000 tokens, but it can go up until 2 million. Of course, I will always tell you what model has what token limit. With all these open source LLMs, we can run these things locally because we can download the run file and the parameter file. And with the closed source LLMs, we can not do that. And one last thing, of course, it's really important what questions we ask the LLM, because with good questions we get good answers. This is called prompt engineering, but more on that of course later. And I see you in the next video. I know we did this a little bit fast, but I think these technical details, everybody should simply have a grasp of this. So we did it fast, we did it not in complete detail, but this is more than enough to work with these models. In the last video you have learned what an LLM is, how these LLMs work with tokens, and in this video I want to show you the OpenAI API, because in the API we can make the API key so that we can plug in into OpenAI, and here we need to pay per token. I want to show you the prices, how you can organize your projects and much more. The first thing that you should do is to simply Google OpenAI Playground. Then you press on the first button here, OpenAI Platform. If you press on these, you can either log in or sign up. It depends, of course, if you already have an account or not. I simply log in. You will be in an interface that looks something like this. And don't worry, we will not work with this interface a lot. This is basically just like ChatGPT. You can work completely similar to ChatGPT. On the right side, you can press and use the model that you want. For example, O3 Mini, GPT 4.5 Preview, and so on. The response is text. Then you can add some functions. You can play with the temperature, basically a lower temperature, and the answers will be more accurate but a little bit less creative, and the higher you go it will be more creative but less accurate. Then you have the max tokens as output. Here you can see this model can spit you out 16,000 tokens all in one prompt. You have a stop sequence and also the top B. You can always go with the mouse over these and see for yourself what these things are doing. Right now for this minute we do not need to play with these. You can also set a system message if you want. You are a helpful assistant and so on. Later in our AI agents the system message will be really important. But the first thing that you need to do is to press in the right upper corner on this thing right here. And you need to press on your profile. Here on the left side you find this thing here, billing, and you need to press on it. And here you have to come to the payment methods. And the first thing that you need to do is, you have to add your credit card. Yes, you have to do this, because OpenAI will bill you as you go. Don't worry, this will not be expensive. I will show you, of course, how much you'd pay as you go. It's also enough if you just upload $5 for the starting. I think you can go through the whole course with just $5, and it's also possible that OpenAI gifts you $5 as you start, because they want that you play a little bit with these models, so it's totally possible that you can do everything for free. But then you have to give your credit card information here. And if you really do not want to do this, of course, you can also work later with open source models, with Llama and so on. But let me tell you, right now at this minute, OpenAI is really good in the things that it's doing. The API from OpenAI is reliable, it's not too expensive, and with a few dollars you can go through the whole course. Let's just see how much the API is costing from OpenAI, so the API pricing. If you come down, we have models like OpenAI 01 and 03 Mini. The 01 model, we will not use this is too expensive for us, but the 03 Mini model, we can absolutely use this. 1 million input token cost you $1.10, and 1 million in output tokens are $4.40. And this model is great for coding, for math, and also supports dual and structured outputs. So this thing has function calling, more on function calling later. So this is a model that we can absolutely use. So what does 1 million token means? Basically, these are roughly 750,000 words. And if you build an agent and just make some tests, like you will not use 1 million tokens. So you see this will be really, really inexpensive. It's cheap. And if you scroll down, you can also use other models. If you use the standard models, I would not suggest you to use GPT 4.5. This is a model that is not great for agents. This is way too expensive. But if we use GPT 4 Omni or GPT 4o Mini, these models are great. The 4 Omni model costs us $2.50 for 1 million input tokens and $10 for 1 million output tokens. And if you just want to test all of this stuff out, you should absolutely work with GPT 4o Mini, because this model is extremely cheap. 15 cents for 1 million input tokens and 60 cents for 1 million output tokens. I think if you use GPT 4o Mini, you can go through the whole course with just $1 and you can play with these things like for a long time. So I would really strongly recommend you to make an account in OpenAI and also give your credit card here. And no, I am not sponsored by OpenAI. No, I do not have any advantage if I say this to you. There's also other stuff in the API. For example, audio models. These audio models are also a bit more expensive. We will not use these audio models. If we use GPT 4o Mini for our audio models, it would be okay. And we have also a diffusion model, DALL-E in the API, and a lot more. Whisper, the list goes on. And if you see something like these models, 01 or 03 Mini or whatever model that starts with 01 and then comes a number, these are always reasoning models, models with test time compute. I want to talk more about test time compute in the next video, because this video is not for that. As soon as you have your account on OpenAI, you can simply start to make your own API keys. And right now I want to show you how you can do this the right way. Let's just come back to this playground. If you are in this playground, you can first of all also come to the documentation, and in the documentation you can read through everything that is available in the OpenAI API. We want to do this fast. So here you find the quick start, the models, the pricing, everything that is included here. But we want to do this a little bit quicker. We come to the dashboard, and in the dashboard you find the API keys, and you can press on these API keys. Here we are in one folder of mine, and here you see I have a lot of different API keys. You can basically come with the mouse in the left upper corner, and here you have your projects. If you never ever made a project, you are in this default project, and this default project will be empty. If you already have some projects and want to create a new one, you can simply press create project. And you can also share these projects with other people. You can give this a name. Let's just say N8N course. And we simply press create here. Right now you see we are in this N8N course here. And here you can press create new secret key. You can give this key a name. Let's just say N8N once again. Owned by you. You can also use a service account if you want, but I would recommend you to stay on you. Then the project, we use this project. Then we have the permissions that we can give. We can give either permission through all models. We can give restricted permissions, for example, only to specific models. And we can also give read-only, or basically restricted with read-only. But 99% of the time you just want to use all so that you have permission with everything to this API key. And if you press right now create secret key, you will get your API key and we can paste this thing in other environments and then we are connected with OpenAI. And please, always stay cautious with these keys. If other people see this, they can use your API key and you will get billed. That's why I will also delete all of these API keys as soon as this course is finished. If you copy these, you can insert it in other places. And if you press done, you see that you can never ever see this key once again. And if you want to rotate your keys, so from time to time I would say that you should rotate these keys, you can delete them by pressing on this button here and press revoke key, and then this key is gone. If you come once again with the mouse on this button, you see that you also have the possibility to manage your projects. If you press on manage projects, you find the projects that are in this specific OpenAI API account that I have created here. And here you see I have some test accounts. I have one test account where I have spent $3.09 in this month, and here you can simply go on with this project. If you have here, for example, this N8N course, you can either press on it and then you are in the right place as previous. You can also delete it by pressing on this button here, or you can come to the settings, press on it, then you have the project name and the project ID. And if you want to disable all API keys, you can press on this button here and then everything is disabled from this project. Here on the left side you have also a lot of different settings. If you come on General, you have some informations. Then here are the API keys, of course, the admin keys, the members that are included. Right now it's only me. Of course you find all your projects here. Here is the billing. You can also set limits. This is important. If you scroll down, you can give a specific limit. If you set a budget where you get an alarm, you will simply get an email as soon as, for example, $10 are reached. And you can also use a limit, for example, like $40, so that you cannot spend more than $40 per month. If you come on usage, you can track exactly how much you have spent in the last days, for example. Here you can see every single day. So on February 19, 38 cents. February 20th, $1.22, 21, 35 cents, and so it goes on. And the most expensive day was, of course, March 3rd with $1.64. On this account, I think I have also 2 or 3 chatbots that are working for other people. That's why I have to pay here a little bit from time to time. And here you get some good information if you scroll through it. You have also data controls. So what should be hidden and what should be visible. You have the verification methods. On projects you can come on General, API keys and members, just like you have seen. And of course also here you can give limits to specific projects. We can give, for example, a budget to this N8N course if we want to. So once again, the fastest thing as soon as you are in this playground is, of course, give a little bit of balance with your credit card, then come to dashboard, use your project, press on API keys and create a new secret key, and then you are basically ready to rock. And you will find everything how much it costs in this overview. And one more thing for developers that are based in Europe, you can also create new projects in the OpenAI API platform, and in the dashboard you simply select Europe as the region. Then OpenAI will not send out your data to the US and you are basically completely safe, you are protected. OpenAI has 0 data retention. And you are also safe if you work or live in Europe and want to do this for your business, for example. So in this video you got the overview of the OpenAI API platform. You can basically come on it, you can give a little bit of balance with your credit card, and then you can create your API keys and new projects. If you live in Europe, you can use Europe as the region and then you are also safe. Normally this should also happen automatically. And this only works for new projects. So if you create a new project and you are based in Europe, this should be fine. You have also learned that these tokens are not completely for free. Basically, we need to pay for the output as soon as we start to use these API keys. And it depends always on the model that you are using. GPT-4o Mini is really fast and extremely cheap. And a model like OpenAI o1 with this test time compute is way too expensive for an AI agent, because this thing has test time compute, and I want to talk about test time compute for a brief moment in the next video, because for some applications also the test time compute can eventually make sense. See you in the next one. I want to talk briefly about the test time compute. The test time compute is basically just so that the models seem to think before they answer. They make chain of thought prompts and basically they can think step by step through your problem. And with this test time compute, it is basically shown that these models are a lot smarter, especially if we talk about coding, math and science. If you come, for example, into ChatGPT and use a model with test time compute, so these O models, O1, O3 mini, O3 mini high, or the O1 Pro mode, these models will simply think. Let's just use O3 mini high and insert a hard math question. If I send this out, this model will generate chain of thoughts. You see, this thing is reasoning right now, and then we will get a better answer. You see it here that the model has thought for 10 seconds, and if you press on it, you can basically see what the model has thought, like roughly, and then you get also your answer back. If we come to other models, for example Grok from Elon Musk, you can insert basically the same math question, so this is a hard math question, and if you press on think, this model will think, will generate its chain of thought. Here you can see it. It will think for a few seconds, and after this model has generated all of this thinking, it will give a better answer. It's the same concept that I am talking to you right now. If I tell to you what is 2 plus 2, you say immediately 4, because you use the system 1 thinking. But if on the other hand I say to you 17 times 9 divided by 3, you have to think through it step by step, and you can also call this test time compute if you want. There's a book out there that is called Thinking Fast and Slow, and basically this level 2 thinking is the slow thinking, it's the test time compute from these models. It happens that the answers are a lot better if we use this test time compute. These answers are a lot more clear, especially in fields like math and code. We are a lot better with these models, but these models are of course also a lot more expensive to use. An open source model that also has this thinking is DeepSeek. If you press on DeepThink on DeepSeek and send this out, you can also get this chain of thoughts here. You see that also this model is thinking. And if we use these models in our AI agents over an API, of course, you need to understand that these models are more expensive because we also create these thinking tokens. These thinking tokens are a lot more expensive than these other normal tokens. And of course, these models are also a lot slower. So you see, until here everything comes through, people need to wait for a little bit, especially if you want to create applications that need to be fast. It's not optimal to use thinking models. And if you create applications that need to be cheap, it's also not optimal. And if you want to create big AI agents that use different tools, it's maybe also not optimal because not every thinking model has function calling included. DeepSeek, for example, has its problems with the function calling, but more on function calling and all of this later. First, you just need to understand what's this test time compute. These thinking models, these models with test time compute, are not great for creative writing. These models are always great for things where we have a logical right answer. For example, math, code or science. In math, we can really say that the answer is right. In normal language, it's not really right or wrong. Creative writing is really hard to evaluate. And so we would never ever use, for example, such a thinking model in an AI agent to create blog posts, for example. This would be not an optimal way. Before you use such a model with test time compute, even if you just work in ChatGPT, always think, if you have a question where only one answer is right, you should use such a model. For example, math. If on the other hand you have a question where more answers are most likely right, like in creative writing, you should use a model without this test time compute. Long story short, the so-called test time compute, this is the next evolution from these AI models. You have already learned how LLM gets trained. We have the pre-training, we have the fine-tuning, and we have the reinforcement learning. And the next step is basically this test time compute that is also relatively newer. This is also pure reinforcement learning. So the model thinks for itself. It is based on pure reinforcement learning, and this thing is really powerful. It will create really good answers, but it's slow and expensive if we use it over the API. More on that later. I will show you later maybe some examples where these things make sense, but for the most part we will use a normal LLM with function calling, and function calling is also the word what we want to end this video, because I want to explain you in the next video exactly what function calling is meaning. Let's talk about function calling. Basically, We can simply see the LLM as a so-called operating system. And this operating system, you already know it, this is really good with text. It can make text bigger or make text smaller. And we do a little bit of prompt engineering so that it's a little bit better. But these LLMs, they are not good at specific tasks. These LLMs are not good in math. And we can simply include another program in order to do math with an LLM. We can simply do the so-called function calling to a calculator and include the calculator in our LLM. These LLMs, they cannot make pictures, but we can do function calling to a program that can make pictures. Generally speaking, diffusion models make pictures. So we can make an API request out to a diffusion model and get the answer in our LLM from the diffusion model. An API request simply means that we send something out to another program and we get it back. This is the simple explanation. We do not need to know more, at least not right now. Basically, we have something here from Andrew Karpathy, and he describes the function calling, or basically the LLM as operating system, with this picture. And I think this picture is really awesome. So you can see the LLM with the context window just like the RAM on your PC. And then we can do this function calling, so we can talk, for example, to other LLMs, and they can communicate back with our LLM. But we can also include function calling to the browser. You can think about the Ethernet. So we can use an LLM, we can ask something that is, for example, recent, and the LLM will simply go and use a browser in order to get the information. We can also do function calling at, for example, diffusion models. And diffusion models can generate, for example, videos, audios, pictures, and much more. And he calls it peripheral devices. So we can simply include different things in our LLM. We can also use stuff like a calculator, the Python interpreter terminal, and much more. So we can, for example, use Python, the Python libraries, in order to make graphs and much more. And Karpathy makes here the example like software 1.0 tools, like the classic computer. So here on my computer, I can use, of course, this calculator, and all of it is working. And then we have also the so-called disk. This simply means that we have file systems and embeddings. You can also call this, for example, direct technology and vector data stores. We will talk about them in more detail in the next video. So we can, of course, also save stuff up in the so-called long-term memory of the LLM if we include a vector database and do some embeddings in these. This is called direct technology, but like I said, more on that later. It's basically just important that our LLM is basically the operating system, and we can include different programs. If we go here on Hugging Face, for example, with this Command R+ model, we already have function calling included. You see right here these tools, so we can make images with this LLM. We can use a calculator and much more. If I ask, for example, what is 88 times 88 divided by 2, and if I send this out, most likely the calculator will do this work. So you see, called tool calculator, we simply include different programs. And in our AI agents, we can also do function calling, just like you see in this agent. This agent can also do function calling to Gmail. It can do function calling to the calendar. And if you want to integrate, for example, a calculator, you can simply press plus and then include the calculator, you press on it, and then this AI agent will simply use this calculator as soon as this is needed. In order that this works a little bit better, we should also come to a system prompt and include here some things, but more on system prompts of course later, because first we need to talk about direct technology. But you should simply understand that we can call a lot of different tools, and this is called function calling. If the LLM on itself is not smart enough, we can include all these different tools and this thing is working. working. In order that this thing is working, we need to use a LLM that has function calling included. For example, the GPT-4o models, also the o3 models. Llama 3 has this included. Basically, a lot of LLMs have function calling included, but not every single LLM. Of course, you will learn in more detail what LLMs have function calling included, but you also find it always in the documentation. Excuse me that we do a little bit of theory in this section, but I think you need to understand this in order to grasp these AI agents a little bit better before you build them. You already know it. All of these LLMs, they have a context window, so they simply don't know for a really long time what you are talking about. But of course we can include different files, and the basic concept is that if the LLM does not know something, for example about our business, we can upload PDFs and then the LLM can browse these PDFs and knows our knowledge. This is direct technology, and as you already know, we can not only use one single LLM that can do function calling that has direct technology, but we can use a lot of different LLMs, just like you see right here. We have, for example, a CEO, and the CEO can call the CFO, the CTO, the COO, and the general counsel. And these LLMs, they can also talk to other LLMs. They can talk, for example, to the security guy, to the VP engineer, to the chief scientist, and also this LLM can go one step further and talk to other LLMs. So basically, these LLMs, they can all talk to each other, and every single LLM can do function calling, can have direct technology. It all depends on the stuff that we want to include. We always have the standard LLM. This could be, for example, a Llama model that we run locally with Llama, but this could also be ChatGPT that we use over the API from OpenAI. This could be any LLM that is able to do function calling, and we can include a lot of different things. We can include vector databases, we can include embedding models, we can include direct technology, and we will do this in all of these AI agent frameworks. And that's why you need to also understand direct technology, vector databases, and embeddings models. And because of that, I want to tell you in the next video exactly how direct technology is working. We need to understand what are embedding models, what are vector databases, and how direct technology works. So in that manner, see you in the next video, because in this video you have learned that the LLM is like an operating system. The LLM itself is not that smart, but if the LLM is not smart enough to do something, it can simply make a call to another tool that is smart enough. For example, a tool that can generate pictures, a tool like a calculator or Python libraries. And that's the magic. Function calling is one of the coolest things that an LLM can do. See you in the next one. If we want to give an LLM additional knowledge, generally speaking, we have two different options. It's either the in-context learning or, of course, direct technology. These are, at least in my experience, the best ways. Of course, we can also do fine-tuning and a lot of other things, but you already know that we can do this direct technology. And in order to understand direct technology, we need to understand embeddings and vector databases. Because we can simply browse a PDF if we upload it, and we can search every single thing out of this file. In AI agent, direct technology would look something like this. We have basically a vector database included. But let's just take this slowly. Let's come back into ChatGPT so that you can see how we can upload knowledge. And this can be everything. It can be a PDF, it can be text, it can be markdown, and so on. But generally speaking, the better you structure your input, the better the answers get. Normal PDFs are most likely messy, but let's just start with the basics. So let's just see this in ChatGPT. Of course, you can give context in the prompt, but let's just say you want to give a lot of context. Sooner or later the context window will be reached. If you want to upload like a gazillion PDFs in this context window, the token limit will be reached. I hope you remember what the context window is. As soon as you have too much tokens inside your context window, the LLM will no longer understand what you are talking about. And of course you have a few options to do this better. One of the best options is, of course, direct technology. If you go in ChatGPT, for example, of course, on My GPTs, you press create, And then you can use this knowledge here, and here works the RAG technology. If you upload files, something cool happens. And these files, they get stored in a vector database. Before they get stored, the embeddings model make them into vectors. And then we can do a search query. And the LLM will simply search your PDF. And now I want to show you exactly how this works. And then of course also how you can make this yourself with every single LLM. So also with open source LLMs. This article from NVIDIA, what is retrieval augmented generation, aka RAG. This is a cool article. It's at least in my mind a bit too long, but I think this picture is perfect. Generally speaking, this is how it works. First of all, of course, we have a lot of PDFs, a lot of documents, a lot of whatever. And we want to upload our documents in a vector database. And of course we need to do something so that this is working. We need to use the embeddings models to embed them in our vector database, and then the user can go on and ask something, and if it makes sense, the user query will get sent to the vector database. So simply the LLM browses our documents and gives us the right answer. And now I want to show you why this is working. First I want to go in Paint. Let's just say these right here is the vector database. I make them simply as one big thing right here. Normally a vector database is 3-dimensional. I will show you this later. Then we have of course the embedding models. So here we have some kind of an LLM, and then we start of course with our PDF. So in our PDF is data, of course. Then our data will get sent to the embeddings models. The embeddings models makes these embeddings. These embeddings, they are just like tokens. These are basically numbers, for example 0.2 or 1.2 or whatever. This embeddings model, they simply make vectors so that they make sense. And these vectors, they get stored in a 3-dimensional space. Let's just assume that we have here one cluster of words that are, for example, between 0.2 and 0.4. And here we have, for example, a cluster of words that is between 1 and 2. And now I want to show you why all of this is important. So basically we use our PDF, and the embeddings models, they make these vectors out of these. So they make these numbers. And if you Google vector database, you also get a rough idea how this works. So this vector database is then of course 3-dimensional. And you know, of course, we get these numbers out. And these numbers, they simply make sense out of these words. So for example, the word apple will be a similar word than banana. And these embeddings, they get these. And the other embeddings, for example, wolf, dog, cat, they have other embeddings. And this is really important to understand. So basically, things that have a value of 0.2, this could be, for example, right now a cat. And this right here, this 1.2, this could be, for example, a dog. And if we come right now and we make a query, we ask something to the LLM will browse this vector database and will search in the right thing. If I ask, for example, something about bananas, the LLM will simply search the vectors that are in the banana space. If I ask something about a monkey, the LLM will simply search in the vectors where he finds all these animals. It's really that simple. Also, here is a cool example. Basically, the content gets, of course, in the embeddings model. Then the embeddings model, they make these vectors. These vectors have different numbers and they make clusters. And then, of course, these clusters get stored in a vector database, and they get stored so that it makes sense for the LLM. And then if we ask, for example, a query, the LLM will go and search in the vector database in the right space what you want to get back. Let's just make an example right here once again. And now we do it completely different. Let's just assume that in this vector database there's a party. And at this party here is the bar. And here, for example, is the dance floor. And let's just assume that a lot of people come to this party. So on the bar there are, of course, the guys that drink all the time some beer. So here, of course, there are some guys and they have fun, they drink beer all night. So this is one cluster of embeddings. Then the second cluster on the dance floor, let's just say here are all the girls that have a little bit more fun than the guys that are just drunk. So here are, for example, the girls that have some fun. And where we are at this party, of course, we are not where the girls are, we are also not where the cool guys are. We are this cluster here, for example, and here are the AI nerds. So the AI nerds, they are here, they don't have fun, they watch a course. Makes sense. Of course, the AI nerds, they have also no muscle, they have no beer, they have no girls. Just like it should be. And now we assume that we are a dad or a mom from one of these girls. Of course, if we go into the party, we know immediately where we need to search her. We will most likely don't go to the drunk guys. We will definitely not go to the AI nerds, but we will go most likely to the dance floor, and me as a dad, I will spot my daughter immediately at the dance floor, because I know she is there. And that's basically how these embeddings in these vector databases work. The embeddings model, so this thing right here, let's just call it embeddings, this make clusters out of these words. Let's just say in this PDF there are, let's just say there are some fruits and then some animals and so on. And these embeddings models, they will make these vectors, these vector embeddings, they get stored in the right place in the vector database. And as soon as we as the user ask a query, the LLM will know exactly where to search. Just like you as a dad or as a mom would search for your daughter at the dance floor and not where all the AI nerds are standing on this party. I think this should make sense. And this is why we can upload a lot of PDFs, because in the vector database there is a lot of space, and these embeddings, they are stored in one small portion, and if the LLM needs to search something, the LLM can search in the right spot. So if the LLM searches, for example, about bananas, it will search at the bananas embeddings, at the fruit embeddings. Just like we would search our drunk son right here at the bar, and if we have a doctor that likes to dance, we will search her most likely at the dance floor. So in this video you have learned, I think, a lot of things. You have learned what a vector database is, you have also learned what embeddings models are, and you have learned why the RAG technology is working. Generally speaking, we can upload some text. It could be a PDF, it could be a CSV, it could be whatever. Then the embeddings model will come and it will make tokens out of our PDF. These tokens, they will get stored as vector embeddings in our vector database. The vector database is three-dimensional and there's a lot of space. And we will make clusters with these tokens. So there's, for example, a clusters with fruits, a clusters with animals, a clusters, for example, with prices. If we have some prices, there are different clusters. And if we ask the LLM something, the LLM can then go search this vector database, search in the right spot, and will find the prices where the prices are, the fruits where the fruits are, and the animals where the animals are. Just like you as a dad or as a mom would search your drunk son at the bar, and if you have a doctor that likes to dance, you will search her at the dance floor. That's basically how all of this is working, and this is why this works so cool. So we have nothing in our context window. The LLM will simply search the vector database and gives us the right answer back. This is how we can give LLMs additional knowledge. This is the best and easiest way to give additional knowledge. Yes, we can do fine-tuning, but the RAG technology is much more efficient and is much faster, and I think you should understand this really clear. And of course, this is also perfect if you want to work with AI agents. Let's just say your CEO gets a task, and you can simply give one of these workers, or every worker, just like you want, you can give them additional knowledge with the RAG technology. So we would simply upload our PDF in a vector database with these embeddings models. And let's just say this is now stored in a vector database. And now if we ask the CEO something, the CEO will use the first worker. The first worker will browse its PDF and give us every single thing back. Let's just say that you are an expert in fitness, in bodybuilding, in dog training, in whatever. You can upload your knowledge, your specific knowledge, or let's just say you are in real estate, you can upload your real estate knowledge, and so one of your workers would have this additional knowledge and can immediately search this knowledge. As soon as this knowledge is searched, this worker will give this knowledge back to the CEO, and then the CEO can go on to the next worker. And let's just say the next worker would be, for example, a creative writer. So let's assume that we tell our CEO, hey, we want to have an article, a blog article about fitness. The CEO would go on and ask the first worker to browse its knowledge, our fitness knowledge that we have uploaded. Then the first worker would give this fitness knowledge back to the CEO. Then the CEO would give this task to the second worker. The second worker would be, for example, perfect for writing creative stories, for example, blog posts and so on. And then as soon as we have the blog post, this worker would give the blog post back once again to the CEO. And then the last worker, for example, could be a worker that makes tweets. Let's just say the CEO gives then also the blog article to the last worker, and this last worker would make tweets out of all of this and then save every single thing locally on our PC. He would have, for example, one tool that can save anything on our PC, and then we have everything. We have our specific knowledge with direct technology from our first worker. Then the second worker would make our blog article, and that third worker would make our tweets and save every single thing on our local machine. And this is how we could eventually include direct technology in an AI agent. So we can come back one last time at this graphic. All of this can work with LangChain, but it can also work with different frameworks. You will learn a lot of them. Basically, we can upload our stuff. The embeddings models store it in the vector database, and then we can use a user query. The LLM can do this so-called function calling and can simply query or search the vector database if it's needed. If it's not needed, the LLM will simply give us the answer back. So if we ask something that is not stored in the vector database, the LLM will not do function calling. So this is function calling with direct technology, and you have also learned what vector databases and embeddings models are. And I see you, of course, in the next video. In this section you have learned some of the basics. You saw what an automation is, an AI automation and an AI agent. An automation is simply an action that occurs without human intervention. You always need a trigger and, of course, an action. An AI automation, on the other hand, is as soon as we start to integrate a brain, for example an LLM. You can write content with these in the middle ground and then post it. You can make sentiment analyses, and you can do a lot more. And as soon as we talk about agents, we have simply the brain, the LLM, that has also function calling included. So some tools, for example sending mails, making posts, using a calculator and much more. To use all of these LLMs, tools and other integrations, other action, we always need to communicate via APIs. So you have also learned what an API is. You can simply make an API key and connect different apps, and they can talk to each other via server and client. You saw that there are a lot of tools out there in order to create such automations and agents. We have N8N, we have Make, LangChain with the whole ecosystem like LangGraph, LangFlow, FlowWise. We have Crew AI, we have Zapier, Agency Swarm, Swarm AI and a lot more. And I think N8N is one of the best tools out there besides FlowWise. Because in FlowWise we use LangGraph but with an easier interface. Then you have learned how the brain of our agents work. It's an LLM. It simply calculates the next most likely token, and it is trained on a lot of text from the internet. In order to plug in these LLMs in our applications, we also need to make an API key in the OpenAI API. And you have learned how you can set up your projects and how much this token costs you to generate. Generally speaking, it's really cheap, and you will also learn how to use open source models. You also saw that we have a lot of different models. Some models have test time compute, and especially for math and code, these things are great, but they are slow and expensive. For creative writing, we will not use them. Function calling is of course simply the calling of other tools, you know that. And a vector database is nothing else as an external store where your information gets stored in context-aware embeddings. And the LLM can browse this vector database and find these context-aware embeddings because they are clustered so that the LLM can find them easier. So basically right now you know all the basics, and if you think these basics can also help a friend of you, it would be of course really nice if you could share this course. If this person also gets value from this course, they will describe the value to you because you have told them, and your status rises a little bit, so we have a win-win-win situation. Your friend can learn, I reach more people, and your status rises. So what we need to do right now is of course to start building together, and that's what we will do in the next section.